Hi everyone, this is the another example on normal form. See the statement of the problem. Find the rank of matrix A by reducing it to canonical form. Sometimes normal form is also known as canonical form. So don't get confusion in our examination. So where A is this matrix C. What is the procedure? Always we have to try to make except diagonal elements to 0 and all diagonal elements to 1. Okay, always try to get an identity matrix of order I2, otherwise I3, otherwise I4. Okay, since it is 4 by 4 matrix, you never get a I5, don't forget it. So solution, once again take the given matrix. In the solution, given that this one. So by using first pivot element is nothing but A11 element, A22 element, A33 element, A44 elements. These elements are known as pivot elements. So by using that pivot elements, we have to make below elements to 0 and these three elements to 0. Okay, always follow this procedure only. After making these three elements to 0, these three elements to 0, look at the new pivot element, which is A22 place element. It may be 1, otherwise not 1, we don't know about it. By using that A22 element, we have to make below 2 elements to 0 and next 2 elements to 0. That is the procedure. You can continue the procedure until to get except diagonal elements to 0. So it is better to make this first pivot element is 1. Okay, since it is 4, it is better to make it 1 by interchanging the rows, otherwise columns. Since here in the fourth column first element is 1, if you interchange R4 and R1, you can get 1 here. Otherwise you can also change last column and first column as you wish. So I am interchanging rows. I am writing R1 in R4 and I am writing the elements in R4 to R1. So the matrix becomes to 1, minus 1, 3, minus 2. Next 5, 1, minus 1, 2, 0, 1, 2, 3. Next write this first row here 4, 3, 2, 1. Now by using this first pivot element, A11 element, make these three elements to 0. For that purpose I am using row operations. R2 implies, since here we have 5, you should multiply the first row with 5 and subtract from R1, R2. Okay. Next here already R3 first element is 0. So don't disturb R3 here. It is already 0, then you can leave it. R4 implies R4 minus, since here we have 4, you should multiply the first row with 4 and subtract from R4. Surely you will get 0 here. I will write the operations here. So what is R2? Write R2 here 5, 1, minus 1, 2. Okay. Next multiply the R1 with 5 and write here 5 into 1, 5. Minus 5, 5 3s are 15, 5 2s are 10, but don't forget negative sign. We have to subtract these both rows, 5 minus 5, okay, 5 minus 5, 0, 1 plus 5, 6, minus 1 minus 15, minus 16, 2 plus 10, 12. To avoid the numerical mistakes, you can use this simple method. R4, 4, 3, 2, 1. Multiply the R1 with 4. 4 1s are 4, minus 4, 4 3s are 12, 4 2s are 8. So we have to subtract these both rows. That's why change the signs. If it is positive, you can make it negative. If it is negative, make it positive. Positive. Okay. 4 minus 4, 0. 3 plus 4, 7. 2 minus 12, minus 10. 1 plus 8, 9. In this way, we can easily find out the elements in the rows. So the above matrix becomes to how 1, minus 1, 3, minus 2. Second row is 0, 6, minus 16, 12. We are not disturbing the third row. So, third row is similar row. 0, 1, 2, 3. Next, fourth row. 0, 7, minus 10, 9. Okay. Now, by using column operations, we have to make these three elements to 0. Don't forget it. Write column operations. Since these three elements are 0, this area still remains. Okay. There is no change in these elements. Don't forget it. So, what are the column operations? C2 implies this is minus 1. You can add both columns. C2 plus C1. C3 implies C3 minus 3C1. Next, C4 implies C4 plus 2C1. After writing these operations, blindly you can write here 0, here 0, here 0. Remaining are all same. So, you can write the elements in column wise only whenever we are applying column operations. 1, 0, 0, 0. This is 0. Remaining 3 elements are same. 6, 1, 7. Next, this is 0. Remaining 3 elements are 0. Oh, sorry, same. Minus 16, 2, negative 10. This is 0. 12, 3, 9. Now, here we have what is the second pivot element? The second pivot element is A22 element. It is 6. By using this element, we have to make below 2 elements to 0 and these both elements to 0. So, better to make this second pivot element is 1. There is a possibility here. Look at the elements carefully. In the third row, we have 1. So, you can interchange the rows to get the operations very easy. Okay. Only that purpose only I am interchanging them. So, I am writing R3 elements in R4 and R4 elements into R3. So, with this operation, the above matrix A becomes to how? 1, 0, 0, 0, 0, 1, 2, 3. Next 0, 6, minus 16, 12. Next 0, 7, minus 10, 9. Now, we can easily make these two elements to 0 by using this second pivot element. So, what are the operations? R3 implies R3 minus 6R2. Since here we have 6, multiply this row with 6 only. R4 implies R4 minus, here we have 7. That's why you can multiply this row, entire row with 7 only. So, I will write the operations here. See. Write R3 first, 0, 6 minus 16, 12. Next, multiply the second row with 6, 0, 6 into 1, 6, 6 2s are 12, 6 3s are 18. Subtract them. 0, 6 minus 6, 0, minus 6 minus 12, minus 28, 12 minus 18, it would be minus 6. This is the third row. Now, what about R4? 0, 7, minus 10, 9. Okay. 0, multiply the second row with 7 only. 7, 7 2s are 14, 7 3s are 21. Subtract them. 0, 7 minus 7, 0, minus 10 minus 14, it would be minus 24. What is 9 minus 21? So, this is minus 12. You can write the matrix. A is equal to, first two rows are same, 1, 0, 0, 0, next 0, 1, 2, 3, next this is the third row, 0, 0, minus 28, minus 6, and this is the last row, 0, 0, minus 24, minus 12. Now, by using column operations, we have to make these two elements to 0. Okay, see the next step. By using column operations, we have to make this element to 0 and this element to 0. Since these both are zeros, these elements are still remain same, don't forget it. You can write similar elements in the next step. So C3 implies C3 minus 2C2 and C4 implies C4 minus 3C2. So A is equal to 1 0 0 0 0 1 0 0 and you can write blindly here 0 and remaining two elements are same, minus 28 minus 24. Next 0 0 minus 6 minus 12. Okay. So according to the procedure, by using this third pivot element, we have to make this element to 0. So but it is 28, I want to make it 1. So you can divide the entire fourth column with 6, because here we have 6 and 12, just you have to observe the elements only. So C4 implies, if you observe the elements carefully, you can easily get the idea, no doubt at all. So A is equal to 1 0 0 0 0 1 0 0 0 minus 20, sorry, this is also 0, this is minus 28 and this is minus 24, 0 0 1 2. Now we can interchange the columns, so you will get third diagonal element is 1. So C3 can be written as C4 and C4 can be written as C3. So A is equal to 1 0 0 0 0 1 0 0 0 0 1 2 0 0 minus 28 and minus 24. Okay. Next, you can also divide the third column with 4 as you wish. Now we have to make this element to 0. R4 implies R4 minus 2R3. 2R3. So this becomes A is equal to 1 0 0 0 0 1 0 0 0 1, sorry, this is also 0, 1 minus 28 0 0 2 minus 2 0 and minus 24 minus of minus 2 28s, it would be 56. What is 56 minus 24? 6 minus 4, it would be 2 and 5 minus 2, it would be 32. So I am writing here 32, positive 32. Now make this element to 0. C4 implies C4 plus 28 C3. I am multiplying the third column with the 28 and add to the fourth column. You will get this element to 0 blindly. So A is equal to 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 32. Okay, you can divide the R4 with 32. So we are observing that here also we get 1 here. A is equal to 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. Here we didn't get any 0 rows and 0 columns, that's why here we can write as I4. Identity matrix of order 4. So A is in echelon form, so that's why rank of A is equal to, sorry, A is not in echelon form, A is in normal form. This is also known as canonical form, don't forget it. So order of I4, it would be 4. In this way we can easily get the normal form of the given matrix and the rank also. Thank you very much. In the next video I will explain another one on normal form. Bye.